As you go through this video, what we probably want to do is stop the video and copy down all the notes as we go through. But what I want to do, I'm not going to go through every particular part, but I want to make notes of what's important and what's different about some of the questions. So in this first one, if you notice, what we're dividing is x to the power of 4, 6x squared plus 6. So when I write it in my notation this way to do the question, what I'm going to do is leave gaps there just in case I get a term that I need to fill in here and I need to bring a 0 down there. So it's a good practice to do that sort of thing. Like, doesn't really make too much difference to this one, but that's what I tend to do there. But noticing that x squared goes in x to the power of 4 x squared times, so the x squared times x squared gives us x to the power of 4, x squared times 2 gives us the 2x squared. Do the subtraction, 6 minus 2 gives us 4. Bring our 6 down there because x squared goes in the 4x squared 4 times. So we get 2 times 4 is the 8. So we're able to do our subtraction of the 4x squared and then do our subtraction and get our remainder as minus 2. If we're looking at terms, let's make sure that you've got a 10x cubed there. And x squared goes in 2x to the power of 4, 2x squared times, and our process continues. Like the 2x squared will multiply by the other two terms to give us this term that these terms we can subtract as we go through. Remember, we're subtracting, so the minus 10 minus 6 gives us a minus 4. We end up adding the 6. So we can see that process stays the same. We keep bringing our terms down when we get to the next division step, until we get down to minus 1, which is less of a degree of the x squared, so because the x squared was there. So, and the 6x is cancelled, so it comes down to just a minus 1 in that case. So again, like, we try and keep, I've written it this way here, but what I try and do is keep the terms in the same degree in the same columns to go through and do that. But you see the dropping down the terms each time. This time we get a remainder of 0, so there's no remainder there, and that would basically means that x minus 2 is a factor of that. We'll talk more about the factors and remainders later on. We've got a few theorems we go through with those. But if we get a 0, it means it's just a perfect factor there. It'll divide into it. Not that it's very easy to do straight out. You can see that again, this one's going to give us a remainder of 0. You can see as we going down each time, we're trying to get rid of the zeros as we go through until we get down to a polynomial that's of a degree less than our divisor. So we're going basically keep going down until we get a constant there. Here's one where we've got x to the power of 5, then 3x cubed. So notice in this case we've got the x to the power of 5, we've left a space for the x to the power of 4, x to the power of 3, x squared, and the x term, there's nothing there, but we do get an x term here. So it's really like having a 0 minus 4 in this case to give us a positive 4x there. So you can see how that starts to work out there, and then there's when we multiply the 6 by the 6x squared to get rid of that, the 6 multiplies by the 4 to give us 24, which means there's no term there, it's just 4x. But we stop at that point. That would be our remainder, because we've got the x squared as the degree of our divisor, and our remainder's got a divisor, a degree less than the degree of the divisor. So x squared won't go into 4x. So that's where we stop. It's okay to have a remainder that is a polynomial as well. That's not a problem. So again, you can see how we have terms missing, but they need to be, and then there's in our dividend, but we need to keep that in mind because we get a 0 minus 4x squared. So it comes down to, and that's okay to have that situation. So keep having a look through the process. It stays pretty consistent all the way through. Again, if you have a methodical way of going through and doing these types of questions, there usually won't be too many hassles for you to make sure you solve them. That's why, and things like leaving the gaps there and keeping them in line. You make sure you don't miss out on terms as you go through, and you don't make those simple errors that can occur, because there's lots of terms being multiplied and subtracted, and then doing that, how many times does it go into, and dividing. So there's lots of terms there. So you just got to take care. Keep in mind that coming down to a remainder that's going to be less than the degree less than the divisor. And once you've got to that point, you need to stop, and because that's as far as you're going to go.